This video will demonstrate how to analyze data stored in audio files using the Audio File Player and the Multi-Tool. Although the File Player tool is available in the Advanced Tools set and can be used for analysis with the other tools in that set, we'll show here that the best way to analyze audio files is with the Multi-Tool, which requires the Pro tool set. You can follow along with this video in Signalscope X or Signalscope XM with the Pro tool set or with Signalscope Pro 2022. The instructions here will work whether you're running Signalscope on your Mac, iPad, or iPhone. Note that tool selection is on the left-hand side of the window instead of the bottom if you're on a Mac. To get started, let's select the Multi-Tool and create a new measurement configuration. We do that by opening up the Tools Options menu, entering a name for the new configuration, and then pressing the Return key or the Done button on the virtual keyboard. This will create a new configuration with the new name. Now let's close the Options menu and set up our measurement configuration. Since the new configuration is just a copy of the previous one, we'll first remove whatever tools are there to make room for the new ones that we want. Now in this video, we'll be analyzing some gunshot recordings that are part of a project to measure the directivity of gunshot sounds. We want to break the sounds down into individual third octave frequency bands, so we'll add an octave analyzer tool. Since the point here is to analyze the data contained in audio files, we'll need to add the File Player tool. Next, let's configure the Player tool by loading an audio file. To do that, click on the Import button. Now we see a list of locations we can add a file from. Local Configuration Folder refers to a measurement configuration folder belonging to the Multi-Tool. Local Folder refers to any folder belonging to Signalscope's own Documents directory. Music Library refers to available audio files contained within your music library. External Source refers to files stored elsewhere on your device or system. In this case, we want to load a file stored on iCloud Drive, so we'll click the External Source and then browse to the desired file. So I've already got gunshots here in my favorites, so I'm going to go ahead and load up the gunshot recordings at the 0-degree angle. Once the file loads, you may see this message asking if you would like to automatically calibrate the selected output channels. This happens when Signalscope detects custom metadata embedded in the audio file containing channel calibration information. This custom metadata is embedded by the recorder tool in Signalscope or SoundMeter. In this case, the microphone units and sensitivity were saved by Signalscope when the gunshots were captured using a special measurement microphone. Since we want to perform calibrated measurements of the gunshot sound levels, let's choose yes. Next, we need to configure our output channel selections. In the channel selection menu, we can see a list of output channels under each channel of data stored in the loaded audio file. The Player tool lets us choose one or more of these physical or virtual output channels as a destination for the playback of the data in the file. Since we don't want to play the gunshot through a speaker, let's select a virtual output channel. The V at the end of the channel name indicates that it's a virtual channel. We don't need to route channel 2 anywhere, since the gunshot data was only recorded in the first channel of the file. Now if we look in the I/O configuration menu, we can select output channels and see that the acoustic units and sensitivity information have been applied to our selected output channel. One more important point about configuring the File Player tool is that we want the hardware sample rate to match the sample rate of the data in the file. If the sample rates don't match, sample rate conversion will be used for playback. Since we're making precision measurements, we want to avoid sample rate conversion. So in order to confirm the sample rate used by the audio file, click on the File Info button in the Player tool. In this case, the gunshot data was sampled at 192 kilohertz. For convenience, we've already connected the RME ADI2 Pro audio interface that was used for the original recordings, so we know it supports this sample rate. Let's go back to the I/O configuration menu to check the sample rate. Okay, the device is currently configured for 48 kilohertz. So let's change the desired sample rate to 192K. And then confirm that the actual sample rate has in fact changed, and there it is. Now let's configure the Octave Analyzer tool for the measurements we want. First, let's open up this tool's channel selection menu and make sure we have the same output channel selected that we chose in the Player tool. in this case, virtual output channel 3. In this case, let's turn off autoscale and manually set the scale to 12 dB per division with a maximum value of 168 dB. Let's also show a secondary level and set it to show peak levels. Next, we'll set the sound level type to LEQ with an indefinite averaging time. Then we'll enable auto stop and set the duration to the smallest available value of 100 milliseconds, since all we want to capture is a gunshot. We'll also configure auto start triggering by switching it on, selecting our chosen output channel as the source, and then setting the threshold to an appropriate value. In this case, let's set the threshold to 100 Pascal so the measurement will only start when the sound level exceeds 134 decibels. Finally, we'll choose a pre-trigger delay of 20 milliseconds to be sure we don't miss anything just before the level exceeds our threshold. Okay, now we're ready to start our measurements. Click the Start button at the top of the screen to begin playback and analysis of the data in the file. Okay, we've captured our first gunshot, so I'm going to pause it. Now, once the measurement is captured, we could save the measurement to a data file. To do that, click the Action or Share button in the top toolbar and select the desired option. In this case, we'll click Save All Data. Now we can edit the name and the type of the data file. We can also choose to have the data saved in the file loaded right back into the analyzer by switching on the switch labeled Keep Data in Plot. Also, since we're using the Pro Toolset, we can add custom metadata to the file. So let's go ahead and do that. Now we'll save it. Okay, let's do one more. Now, notice that when saving multiple files with the same name, Signalscope will automatically start numbering them. Another thing to note here is that you can select just a portion of an audio file to analyze. And you can enable repeating playback for cases in which you would like to let the analysis run for a longer period of time. To end, here is the polar plot showing the directional nature of the gunshots at different frequencies. If you have any questions about how to get the most out of Signalscope, please visit us at faberacoustical.com.